So the first, before we start the lesson, can you hear me? So the first, before we start the lesson, can you hear me? So if you can hear me, just write on the chat box that we can hear you. Then I will proceed. So if you can hear me, just write on the chat box that we can hear you. Then I'll. So I'm from another event, so that's why I delayed kidogo. But don't worry, our kesha, our mall night is still on. So we just want to work on 1 to 1 2. Monica Wanjiku anasema you can hear me, but anasema there's some echo. So those who are watching me, kindly confirm you can hear me. We want to start our lesson right away. The mall. Can we start our lesson now? So let me share the link with other people so that we can proceed. Some people are telling me that when the lesson starts, kindly, yeah, let me invite them right away. So let me share the link with other people so that we can proceed. In the meantime, tell me where you are watching us from, which school are you watching us from, or which school? I'm sharing the link. This was just a minute. We have a long night to go, so tusikue na haraka sana. We have a long night, all the way up to 12. Yeah, now we can join those. I think I've sent the link. You can join me. I want to see that number growing. I think we are okay. Thank you. So there is one thing I want you to confirm to me, that you can hear me. Ingine tutasort out. So apart from Monica, who is saying that she can hear me but kuna some echo, I want 2-3 people who can hear me. Ndio tuanze the mole concept. We are going to take some time, so usikuwe na haraka, kuwa na calculator around, kuwa na karatasi. So the 8 of you are there. Can you just write that you can hear me or not? So that I can know whether to proceed. Can you hear me? Thank you, Olivia Shiro. Shiro has made our lesson now start. Amesema loud and clear. But some people are still telling me that there's some background noise. I don't want to worry about that because they will not keep us from moving forward. So I want us to discuss this topic, the mole. And as I was saying, we are going to take some time. I hope you have taken supper. I hope you have a pen and a and a paper and a calculator like this, because you know very well that tomorrow we will involve explanation, we will involve calculation, it is going to involve very many things. If I ask you a question, kindly respond from the chat box, the side box that is there. I'm here. If you can see what I'm writing on the board, please tell me. If you cannot see, still tell me that you cannot see it very clearly. But this is the board that we are going to do our calculation here. Well, I wanted to use a blackboard. Yes, lakini nikaona blackboard. Now there's a generation of some of us who have never used the blackboard, so they may run away from class saying, "What is this that the teacher is writing?" But next time I will use a blackboard. Don't worry. Can you see the word mode? Can you see what I'm writing on the board to relay? Can you see? Yes. So now, let me start the lesson officially. The mole concept is the second topic of the chemistry form 3. I'm going to focus my content in the KLB, this one. Why am I going to focus on this? Because this book has been donated by the government of Kenya to every student, to every person, so no one needs to buy. It is already there in the schools. Number 2, it's the book that the national exam is tested from. So personally, I chose, or I'm choosing to work with KLB. The students whom I teach, I told them to stay with KLB because it is the book that I'm going to use while we are carrying out this lesson on the mole. So I invite you. This lesson is for all the Kenyan students in all the corners of Kenya, in all the areas of Kenya, and outside Kenya. I have followers all the way from South Africa. I was telling my students. I have followers even in Qatar. I have followers everywhere. But I want to dedicate this lesson to one school, the Loreto High School, Limuru. This lesson is yours. You can share with the other. Do not be me. What I want us to do, I decided to work on this lesson, the mole, this night, before our official lessons starts on starts on Monday. I think I shared the timetable with you. So, but this one you don't need to pay anything. It's just a free of charge. As long as you have strong panels, it is free of charge. But if you want to support Ambassador Foundation, because we still have a long dream to go, we still want to improve on everything about our studios. We want to still improve on lights. Later on, I will be displaying maybe a baby for Ambassador Foundation. For those, after learning this, you can deposit anything that you have there. But I'm saying it is free of charge. But the thing that we also request you to do, you can subscribe, you can share our channel widely. Our channel purposely is meant for learning, nothing else. Even sometimes I do some other teachings which are outside chemistry, physics, or math, what we call the live teachings. So that is what we always focus on. JC says, I can hear you. I hope you can still hear me. Those who are coming in, it's not a sin, it's not a mistake to drop a text, whether you can hear me or whether you can. Very many things that moles involves. You know, when you take tea and you feel like the sugar is less or it is more than, you have used the concept of moles to tell that this sugar is less or it is more. Why? The concentration of the sugar in the tea. Or even right now as I'm talking, one thing that I know, somebody has been slapped right now because ameweka chumvi nyingi kwa chakula. So how did the mom knows that hii chumvi imekuwa nyingi? Mama alijua hii chumvi imekuwa nyingi wakati alionja. So that's concentration. So there are very many things that we are going to focus on. So let me tell you what we are going to see tonight. First of all, we are going to talk about the mole. That is the topic. And all the definitions I'm going to work or to mention, or all the laws I'm going to state, I'm going to give you directly as they are from the KLP. Nobody will ever wrong you if you write or use a concept from the KLP. I know. Book and a pen. So the first thing I'm going to focus on, we are going also to talk about moles and the relationship between. Also, I will talk about stoichiometric direct. We have back titration and we have redox titrations. We will also talk about as far as moles is concerned. We will also talk about as far as moles is concerned. I will talk about volumes of gases when gases combine. How do they do so? I will talk about the same. Lastly, I will talk about the Avogadro. So I wish you a very nice lesson as we are beginning from this. So our first concept, or okay, there are things that you need to know as far as moles is concerned. When you are being taught in Form 2 about writing of equations and chemical formulas, they are really the part of the things that you need to know. Those who are joining me, kindly be texting me at the chat box so that I can know that you are following me. You know, sometimes when I'm talking alone, you know, there is no one around here. So be texting me aside there. Be texting me so that I can know you can still hear me. Just say we can hear you. So I'm saying this. One concept that before even we start our lesson, I expect you that you know how to write chemical formulas correctly. Yes. Number 2, I expect you that you know how to write chemical equations vizuri. One of the equations that we have to write, for example, is a reaction between sodium hydroxide and HCl. Do you know what are the products formed and how to balance the equation? Because balancing the equations will help us solve some concepts in moles. That is the concept I expect you that you know. If you know those that I've said, if you know how to write those chemical equations, if you know how to write those chemical formulas, then you're one step ahead. You're one step ahead in moles. So I want us to start by defining the term mole. The definition of mole is as per how you know it. You know what? In Form 1 physics, whereby we said the mole is one of them, and amount of substance was said. So how do we define the mole? We define the mole this way. It is the substance that contains Avogadro's number of particles. Sometimes the number of particles that we are talking about can be replaced with the word ions, can be replaced with the word atoms. It can also be replaced with the word particles. So someone can decide to say it is the amount of any substance that contains the Avogadro's number of, number of particles, ions, atoms, or molecules. So it is actually the same thing. That's why we will be required to calculate molecules at some point, ions, atoms, or particles. So, but I just chose to work with one. I say it is the amount of any substance that contains Avogadro's number of particles. Now, this Avogadro's number is a constant that nobody can change. It's a constant that talks about, you know, it is just 6.023 times 10 power 23. It's a nobody will change unless you when you manafika sai mkuje change, but it will remain as the Avogadro's number, 6.023 times 10 power 23. I've changed the settings of my camera to be at least clear, though you will see some borders. Don't worry about those lines. It's part of what we are talking about. Now, I think now it's clear. You can see what I'm writing on the board. Millicent Bila is saying that he can hear me. Thank you so much. We can proceed on. So everybody knows how to define the mole. Now, what is relative mass? When we talk about relative mass, what I mean you are supposed to be given which some constants are not being given. Actually, it's not a mass that the equation to be cancelled, because you guys, you know the constants. Right now, especially the form force, there are some constants that you should always be knowing. Always. You should be always knowing those constants. Not a mass to be given. As long as you know I remember Avogadro's constant, you don't have to be given. Yeah. So we know what is a relative mass. Now, molar mass. Define the molar mass from where you are. How do you define the molar mass? How do you define the molar mass? The mass in grams of 1 mole of a substance. That is the molar mass. 1 mole of a substance, its mass is called molar mass, and we are going to calculate it per time. We are going to calculate the moles and the molecules. But let me illustrate in a little bit how we can calculate. Let me use this oxygen atom. So there is a difference between oxygen molecule and oxygen atom. Molecule is when more than one atoms have combined. But kidogo, when okay, I will shed light baadaye when we'll be talking about the group 8 elements. The atomicity is 1. Tutaangalia baadaye. But I wanted to see the difference here. A molecule and the atom. Now, oxygen can exist as a molecule. That's why we can write it as O2. Sodium cannot exist as a molecule. It only exists as an atom. That's why it will be very wrong for someone to write sodium this way. This is very wrong. It's not allowed. Why? Because sodium exists as an atom. As an atom. As an atom. Sometimes you are told calculate the number of molecules. Calculate the number Yes, so don't worry. Sometimes I'm alone here, so like last time when you operate camera, nikirudi hapa. Now, lazima utulize. When you are defining mole and when you are defining the molar mass, so 23, meaning 1 mole of sodium has to yes okay, so now we were calculating a question on sodium whereby we have said how can you calculate the number of atoms sodium, or how can you calculate the number of moles of sodium? Any of the two can work out. Now, if 1 mole contains 23 grams, what about the 6 grams that you have been asked about? So it's going to be 6 times 1 over 23, then you will get the moles. So actually, I was deriving for you the simple way of calculating the moles. So in short, if you want to calculate the moles, let me start with the moles first. You will get the mass of what you've been asked for, which is now the 6 grams. Then you divide with the molar mass of that particular element you are dealing with. So you will be given a question. Then down there, you are told Na is maybe 23. So in short, you are told the molar mass of sodium is 23. You may not be told to gram, or you will actually be able to capture. Let me give you an example from our post book. Those who have this can turn to page. Yes, so let me take you to page and I will give you one question over there. Someone is asking you a question. How many moles are there in 3 grams of carbon? How many moles are there in 3 grams of carbon? What is there in this? For you to get the the moles in 3 grams of carbon, first of all, you must know the molar mass of carbon. The molar mass of carbon is 12. And applying this, that the moles is given with this formula that now let me use this. MM will stand in for molar mass. I will not be writing molar mass all through. I will be writing MM. So what am I saying? So if you want to calculate the number of moles, it is simply mass over the molar mass. So in this question, you've been given this. You've been told to calculate the number of moles in 3 grams of carbon. First of all, what is the molar mass of carbon? It is 12. So it's going to be mass over the molar mass. So it's going to be mass is 3 grams over the molar mass, which is how many? Which is 12. So using your calculator, you will just have 3 over 12. What's your answer there? If you take 3 over 12, what will you get? Your calculator. I want to see the exact number of decimal places. So you will have 0.25. 0.25. 0.25 moles. So nataka ushike kwanza ndio tuitumie mahali. That if you want to get the number of moles of a substance, you simply use the mass and the molar mass. The molar mass will be given to you by the person giving you the question. Bila Melorate, thank you. I hope you can see the screen. It's well, we will wait. Yes. Now, another question in here is mass is 4.6. And are we talking about sodium? Yes, it's 23. In fact, you will be given. So you take your calculator, 4.6 divided by 23. What do you get? That will be the number of moles of 4.6 grams of sodium. Then you've been given calculate the mass of 0.25 moles of beryllium. Now in this one, we are not calculating the moles, we are calculating the mass. So as long as you have this formula, you can, and be given two of them, you can get the missing one. If you are given the mass and the molar mass, you can get the moles. If you are given the moles and the molar mass, you can get the mass. So in short, let's write the three main formulas here. The one need to measure moles is given by mass over the molar mass. If you want to get the mass itself, it's going to be moles multiplied by the molar mass. Don't means multiplication, but I can still write it this way. Now, someone who wants to calculate the molar mass, how do you calculate the molar mass from our formula there? If you want to calculate the molar mass, you make it the subject of the formula, so you are going to have you get the molar mass. So now in our anataka to calculate mass. Na beryllium iko na molar mass of 9. Na hiyo moles tumepewa ni 0.25. So it's a matter of taking your calculator, then you multiply 0.25 multiplied with 9, then you will get the mass in grams. So because you are calculating mass, then you have to input a unit which is grams. But in a case like question 4 reads, for those who don't have this book, question 4 reads, calculate the molar mass of an element. Calculate the molar mass of an element. Calculate the molar mass of an element if a mass of 5.6 grams contains 0.1 moles of the element. Now in this, playing with these formulas, you've been given the mass and you've been given the moles. Now you are told to calculate the molar mass. So you take your mass, which you've been given, which is 5.6. Then you divide with the number of moles given, which is 0.1, and you will get 56. So that 56, for me, I will not put the units. Why am I not putting the units? I have just found my answer is 56, and I have not put any units. But my answer here, 0.225 times 9 meaning that, let me take this times 9, you will have 2.25. So my answer here, I will write 2.25 grams. But in this one, I have not put units as grams. Why? Because this one is mass, which requires that you put it in grams. This one is a molar mass, which I told you it is a relative mass actually. So which states that it's does that unit because it is a relative, it is compared to, meaning the unit is going to cancel each other, it will stay with no units. That is it. Those who are joining me, you can make a comment there. Someone called Sundas amesema good, meaning he can hear me very well. Now, let me take you to Form 2 kidogo. In Form 2, the first topic, we were taught on how to write the chemical formulas and chemical symbols. What's the difference between a chemical formula and a chemical symbol? Let me explain it in a minute. What is the difference between a chemical formula and a chemical symbol? If you want to write this, okay, look here. We have carbon. For example, let me use the example of carbon. We have carbon, which is written as carbon. Its symbol is C. That is chemical symbol. Now we have carbon 4 oxide. Carbon 4 oxide. Carbon 4 oxide is a compound. So if it's a compound, we are not going to talk about a chemical symbol. We will talk about chemical formula, which will now take us to. So this is a chemical symbol, this is a chemical formula. That is the difference. And there are many formulas, but actually they are not. There are formulas which have two elements, made up of two elements like this, carbon, like sodium carbonate. Then you see it's made up of sodium, it's made up of carbon, and it's made up of oxygen. So it is called a chemical formula. But if you write sodium alone here, this one is regarded as a chemical symbol of sodium. Now, there's some brainstorming questions here. You're told to write the chemical formula of carbon dioxide. I think that one we have written it here. Carbon dioxide made up of one carbon and two oxygen atoms written as CO2. Hydrochloric acid. Let's just write them very fast. If you are, I told you to have your chemistry down. Those people that who are lucky to have met with me. So to mesema carbon dioxide, you simply write as CO2. Hydrochloric acid is written as HCl. I hope you know why they are written so. I will use one example to illustrate how to come up with chemical formulas. While I'm writing this in our next chapter of moles, how will be required to use this. So I'm just giving you a hint on what is awaiting us. Then we have sodium carbonate. That is it. We have calcium chloride. Calcium chloride. One calcium atom, two chlorine atoms. Calcium chloride written that way. We have sulfur 4 oxide. You know, when we talk about sulfur, it has various oxides of sulfur. That is, we have sulfur 4 oxide, sulfur 6 oxide. Now, when we talk about sulfur 4 oxide, now sulfur assumes the valency of 4, and therefore the formula of sulfur 4 oxide is going to be SO2. Why? Because sulfate, as we are moving on. Yes. Those who are coming in right now, welcome and join us on no empirical formula. And which concept do you need for you to calculate the empirical formula? We need the concept of, for you to calculate the number of moles, you need to have the mass and the molar mass. That's why, as we are heading on, when two elements combined, two or even more, but I will start with those two. When two elements combine, for example, when magnesium and oxygen combine, it forms magnesium oxide. And the formula will be MgO. So, for example, MgO. So this one will be regarded as the empirical formula. We are going to see how we can go about this. Secondly, if several compounds of magnesium oxide combined, it will form something called a molecule, and we will call it molecular formula. For example, you may realize that we have Mg4O4. Why? Yet we know very well that in the laws of writing chemical formulas, this one should have cancelled out. It's not going to cancel out now. So it will just remain as Mg4O4. Why? Because we are talking about a molecule. We are talking about a molecule, and therefore it will be said to be molecular formula. So let's look at this example. We are heating magnesium. We are heating magnesium in presence of air. You know what will take place. When you heat magnesium in presence of air, it is going to combine, and the product formed will be magnesium oxide and magnesium nitride. Remember, in air we have oxygen and nitrogen, which will combine actually with the magnesium. But in this case, I want to focus on one of them, which is magnesium oxide. Magnesium is going to combine with oxygen to form magnesium oxide. So there's a process given there, and very well explained. Sundas, can you hear me? Can you hear me? Amba JC, you can tell me if you can hear me so that we can proceed on. Now, before you react sodium, magnesium and oxygen, we have to clean magnesium ribbon. we have to clean magnesium ribbon. So there are some questions given there. I told you we will follow the ones in the KLB Fisuri. Why are you supposed to clean, or why is it necessary that you clean magnesium ribbon before the experiment? Someone can tell me. There is an oxide layer that always prevents the further reaction to the inner part of the magnesium, so it has to be scraped off. A very thin layer, so it has to be cleaned. That is the reason. So ideally, once you lift it, then you close it. Number 4, explain why it was necessary, or it is necessary to heat the crucible and its no further change in mass. You heat until it doesn't change in mass. You know, at the beginning, you are able to heat the magnesium, the mass will increase. Why? Because magnesium was combined with oxygen from the air. So inaongezea the mass. But after some time, even when you heat, it will now, be constant. It can increase in mass again. Why? Because it had reacted with all, will remain constant. Somebody again, I asked you about question, what mass of magnesium and oxygen combine to form magnesium oxide? So verse here. Yes. Then you ask how many moles reacted, and get the moles of each one of them. How? We say this. Moles. We have the moles for magnesium, we have the moles for oxygen. The one with the least moles we divide across the experiment. When heating magnesium in presence of oxygen, what could be the source of error? We have very many errors here. Number 1, at some point, all the magnesium may have not reacted with the oxygen. So meaning there's a part of magnesium that has not reacted. That one can be one of the errors. Or no, let's work with that one first, because it's the main error. For us to operate with this question, we must start by identifying the reacting elements. In magnesium and oxygen, remember we are in the road to identify the reacting elements. We identify the reacting elements. Then 0.56. That is the second step. That is the second step. You identify. Get the simple ratio of the moles. You take this, divide by 0.031, divide by 0.035. That is, sorry. Then you have this, you get 1. You have this, you get 1. So meaning magnesium is 1, oxygen is 1. So someone who is starting to discuss this will be talking about, will be saying magnesium 1, oxygen 1. This one you are correct. For a scientist like you and I, if you write MgO and oxygen is 1, so it is magnesium oxide. Example, we follow the same thing. Let me use this. Okay, there's an example here given which reads an oxide of silicon was found to contain 47% by mass silicon. What is the empirical formula of the oxide? So when you are told the oxide of silicon contains 47% by mass silicon, automatically the remaining percentage is for the silicon and oxygen. Now shaambiwa 47% is for silicon, so it can be used the same way we are using mass here, because it is the percentage. I will use the percentages as the mass here. If the silicon, these ones are going to remain the same because we are going to follow the same thing. This one I'm just going to change it equals silicon. 47%. Automatically, common sense will tell us this is 53. And that being 53%, then you go ahead and check from that question, because you must have been given the molar mass always 28 and this is 16. Then from there calculate their moles. How do we calculate their moles? It is the mass over the molar mass. Now in this case you simply have to agree that given the percentages, it is the one that will act as the mass at that particular time. So you take your calculator, 47 divided by 28. 47 divided by 28. So you simply have to key in aina maneno mingi. 47 divided by 28, what do you get? In this case, I got this 1.67857. I can write how many. Yeah, it's okay. Then in this other case, we have 53 divided by 16. What am I getting? I'm getting 3.3125. So you see now, the moles are not the same. So we have to get the simple or the simplest ratio. How? Between 1.67857 and 3.3125. This one is the one which we can say it has the smallest number of moles. So we divide by 1.67857 across. Why? So that we can get a value here which is 1. So we divide by 1.67857. So you cancel it this way, you get 1. Now that one we simply divide it by 787. Then you will have 1.973. Now listen here. Listen here. If you get it as a decimal place this way, there are two things that you can do. You either multiply by 2 on both sides, if by doing so will remove the decimal. For example, if this one was 1.5, I would simply multiply by 2 on both sides. Then it will remove for me the decimal place. But because it is 1.973, a value which is so much close to 2, what am I going to do? I'm going to round off this. Then I have 2. So meaning, for my oxygen, it is 2. And for silicon, it is 1. So what will I do here now? I will have silicon and then oxygen to be 2. That is the formula for silicon oxide as per what we have done. So be very keen here. I will find one that will require us multiply with 2. Be very keen when to round off and when to multiply with 2. That is, if by multiplying with 2 gives you a full number or a whole number, then do so. If not, round off. Sometimes you can get one like, for example, one of the values gives you 2.101. Common sense tells you this one remains to be 2. Yes. So there's another example here. The percentage composition by mass of an oxide of iron is 70% iron and 30% oxygen. Determine. So what is molar mass? Molar mass of iron. I have to take the smallest one is because if you can take 1.875 here, then you bring it on the side. Formula, which is still a chemical formula, we don't have to work with a decimal. So we are going to multiply by 2 here, then multiply by 2 here. What do we get? We get 2 and 3. So what's our empirical formula? It's going to be Fe2, this one, and O3. That is the empirical formula. I hope we are aware with the empirical formula. Unless kuna mtu kuna swali, we can move to the molecular formula. Can you still hear me? Am I still audible? Millicent. Hear me? Am I still audible? Millicent. Yes. So now let's look at the molecular formula. Molecular formula is simply the empirical formula which contains several formulas. Now, I'm going to only use 2 illustrations here from our book, then we will get it. There's an exercise given there. I know I cannot do it because of the time. We have exercise 2.5, which, you know, for 2.1 we did together to kafanya hapo 2 examples I've left you can still work on it. Now we have exercise 2.5, which I can tell you to work on it. Ukipata imekushinda, you can seek assistance from someone who knows it, or those who can reach within me. You can just send the question, we can do it together. So work on it. Now, I want us to work on the molecular formula, and I'm telling you that either difference. Even this ones, it is. Look at this question. I want to read for you a question here that will enable carbon. Hydrocarbon was found to contain 92. So in this, let me tell you, first of all, we have to go ahead and calculate 0.3. You ingine 100 minus. Several of these is combined to give us a formula which is bigger than this. So we don't know what is the molar mass of C we require it. It is 12 plus that one of hydrogen is 1 into bracket N to be equal to 78. So we will have 13N being equal to, just keep your calculator. Okay. Those who have done math so much can tell you they know the answer even before they do it. So we have 6. So what will be your molecular formula? It's going to be C6H6. What's the speed of the network? We are boys para upale. Ile tuwaweta tusaidia sana. We come and coding with telephone. Yes. We come and coding with telephone. Sometimes back. Same lesson. We just come and continue from where you teach more. We first stop it there. Yes. Let's tell that way. Yeah? We do what is humanly possible. We do what is humanly possible. Hauna makosa. Nini sasa wewe? Shida yako ni kudhani umependa. Sivyo. Shida yako ni kudhani umepiga lesson nzuri. Bwana kusikiza. They can hear you. No, shida yako ni kudhani you are failing by the way. The point is, you've done your best tonight. Is that okay? Yeah. Ile siku ya physics math chem tutapai data na tukua na wifi kwanza wifi yangu ni slow. Now we have a technical error here about the network, so inakuja ikipotea end it there today.